Hello, welcome to my YouTube channel. Today I am solving a puzzle that I set. It's called Another One of These Things. It is named, it's the second puzzle like this that I've done. The first one was called One of These Things. That's why this one is called Another One of These Things. The rules are relatively simple. Normal Sudoku rules apply. The digits 1 to 9 appear in every row, in every column, in every 3x3 box. 1 through 9, once each. Yin Yang rules apply. This whole puzzle can be divided into some regions, two different regions that are each region, all the digits are orthogonally connected to each other. Orthogonally means side to side, not diagonally, just that they are connected side by side. And if there's two regions in the entire grid that are all connected, you're going to end up with something like this. And one of the rules about Yin Yang is that you are not allowed to put any 2x2 region of any, or a 2x2 square of one of the two regions. You have to have no 2x2s. There's also a corollary to that there's no what's called checkerboarding. Checkerboard would be like these two cells here. If those were both yellow and these were both blue, there is no way to orthogonally connect both the blues to all the blues, and then for the yellows to connect orthogonally as well. Those yellows, this yellow could not get out of that ring to get to the other yellow. It's one of the ways to work through Yin Yang Sudokus is if you see a checkerboard that might happen, you avoid it, and you know you're correct when you do that. This is one of these things is not like the others. The same rule that I had in my first puzzle that I set. In each one of these cages that are outlined with dashed lines, one of the cells is in a different region than the others. That means that in the Yin Yang puzzle, when you're graphing out the Yin Yang on this entire grid, in each of these cages, one of the cells is going to be in a different region than all the other cells in the cage. And if there's a sum clue, a couple of these cages don't have a sum clue, but if there is a sum clue, the sum given is the sum of the others, not the one. It's the sum of all the others in the cage that are all in the same region together. Digits do not repeat in the cage. And there's black crop key dots in the cage, or in the puzzle, I mean. And orthogonally adjacent digits that are in a 1-to-2 ratio are separated by a black dot. Okay, those are the rules. I'm going to solve the puzzle now. You can pause and go try to solve it yourself. I'll put a link in one of my comments. I'm not allowed by YouTube to link it in my description of the video. I can't put external links in my description because I haven't gained enough support on YouTube. So you might consider liking and subscribing just to help me out and help me get some kind of cred with YouTube so that I can work a little less to get these things out there. Before I start solving the puzzle, I'm going to give a hint. So if you don't want to hear the hint, please pause now and go try to solve it. Okay, here's the hint. The Kropke black dot rule, the way I worded it, I intended to say that there is a negative constraint. In other words, if there's a black dot, the digits on either side of the black dot are in a 1-to-2 ratio. If there is not a black dot, the digits next to each other cannot be in a 1-to-2 ratio. That's called a negative constraint. Please comment on that if you think that that's a good idea for me to leave the rule as I wrote it, or if I should change that and just say negative constraint. All black dots are given, something to that effect. Okay, here's the solve. First of all, I start with the Kropke dot pairs. Wherever I see Kropke dots, I'm just going to shade all those cells. I'm going to shade them light blue so that I can see my pencil marks once I'm doing that. Get all those Kropke dots marked blue, and everything else that is not a Kropke dot is orange, where I see 6 Kropke dot cells on a line, column, or row, or in a box, I know that I've got all the crop keys and the rest are the 579s. And by the same token, if I've got all the 579s, I know the rest are crop key dots. So all those are blue, all those are pink. This cage here has 789 and a digit we don't know. I'll say it's an A. This is not the 7-9 because it is a blue dot. The 7 and the 9 are in those three. I'll mark those pink. But these two cells are in a column with two pink cells, so only one of them can be pink. This one is pink. It's not the 8. It's not the A. It is a 7 or 9. This is a cage that sums to 29. I'm going to let you in on a secret here. This is my first corollary. Crop key dots sum to, the digits on black crop key dots sum to 24. That's 1, 2, 3, 6, and 4, 8. That total of that is 24. And so when you see a cage like that, that's, you know, one of these things are not like the others, Sudoku, you know that the crop key dots are total 24, crop key dot digits, I should say, and that you need a 5. So there's a 5 there and there's a 5 over here, because it's also a 29 sum cage with 6 crop key dot digits. So there's a 5 in each of those. These two are 7 and 9. Now I know that this is from 5, 7, or 9. I know that in this cage I have a 6, 8, and 9, and a, let's say a B. So I've got a 9 there, I've got a 9 in one of those three. That's all the 9s that are in those rows. These are not 9s. That's a 5, 7 pair, and this is a 9. That makes this a 7. This is a 5, 9 pair down here. This is a 7. This is these digits here are crop key dots. I'm going to call them unadulterated pairs of crop key dots. By unadulterated, I mean that the 1 is always with the 2, the 3 is always with the 6, and the 4 is always with the 8. And that's my corollary 2. Corollary 1 being the crop key dot secret, the 24 sum. Anyway, these are, how did I end up with that? I just wanted to add a shade to those. There we go. I just have to get that right. This is supposed to be that lovely light rose color, or coral. And I'm going to hashtag those red. Okay, so those red digits, they're not red, they're blue. What am I doing? I'm really confused here. Those are blue crop key digits. I'm going to hashtag them red. Now in this cage, we have 1, 2, 3 pairs of crop key digits. And we know that those 3 are also the unadulterated pairs. The 1 and the 2 are together, the 3 and the 6 are together, and the 4 and the 8 are together. There are no 2, 4 pairs across these black crop key dots. So this is not the red because that's a red. This is not the red because that's a red. This is a red. And that's the other red. And the other way to think about this is that this cell needs to be repeated in that column, and it has to go there with its partner because it's on a row with all the dots showing. This over here is a blue for the same reason that these are reds, these are the blues. I don't know whether this is a green or a red. I'm going to mark it yellow to differentiate it from this one, which I'll mark orange. I know this is not an orange, this is an orange cell because it's not a yellow, it's not a blue. And the other orange, because those are unadulterated pairs, the other orange has to be somewhere in here. It can't be next to there because of the negative constraint. So that's the orange and light blue, and this is a pink. Now what can I do with that? This is a blue because I've got 3 pinks in the column. And now I've got a 5, 7 pair over here. I've got a 5 somewhere down in one of these 3 rows, or it's here, but that's all the 5s in these columns. There's no more 5s left in these columns. So the 5 is over here. This is a 7-9 pair, because it doesn't have a 5, but it's not a 7 because there's a 7 in the row. So this is the 9. This is the 5-7 pair. That 7 sees over here. That's a 9. This 9 sees into that. There's only one 9 in the cage. So there's a 7 over here. This is a 5-9 pair. This is a 5-9 pair because there's a 7 in the box. That 5-9 pair in the row sees that cell, which is a 7. This is a 5. This is a 7. And this is a 7. This is not a 7. It is not the A. It's not white. It's not the 7. It could be the A. And it's not pink. This is an 8. How do I know that? These are counting cells. The 5 is a counting cell in that cage. Let's just mark these, just for a minute. We're going to mark these dark blue and mark this one, just this super light green. If that were, if this were not a counting cell, the 8 would have got marked 8A as light green. It's in a 4-cell cage where 3 of the cells are counting. Those 3 cells would all be there. They would be the opposite color. They would all be dark blue. And this would be trapped there. It has no way to orthogonally connect out through these dark blues. That's why I know that's a counting cell. That's my corollary 3, and I don't know how to word that concisely. I tried writing it out, but it's not to be. Okay, this is this is a pink. These are blues. This is the 8. This is not an 8. There's not an 8 over here. There's not a 9 here. These digits are 1, 2, 3, 5, and C. And these all could be C's. This 8 cannot go on that Kropke dot. That cannot be C and be on the Kropke dot because if it can't go in a pink cell, it can't go in either of those blue cells because if it did, it would have a 4, and an 8 and a 4 doesn't leave me room in this box to have a 1, 3, 5. 1, 2, 3, 5 in those 3 cells. The 8 is down here, and the 8 is over here. So the 8 goes here. Well, that means that this is an 8-4 because it's an unadulterated pair of Kropke dots. That 8-4 sees that 8. Okay, can this be? Well, let's just check over here. This is a Kropke dot group. It's 1, 2, 3, 4, 6, 8. These are not the 4. These two are not 4 or 8. There's an 8 here and an 8 there. These are not 8s. There's a 6 here, and if there were a 6 here, there'd have to be 2 6s, a 3 and a 6 diagonally. But since there's a 6 here, there are not 2 6s over here, so that's neither a 3 nor a 6. That's a 1, 2 pair and a 1, 2, 4. This is in a cage that's all unadulterated pairs, so that the 1, 2s go together. This is the 3, 6 pair because this is the 4, 8 pair. This over here, okay, this is not the 3, 6 pair. This is not a 1, 2. Because that 1, 2. If this were the 3, 6 pair, both of those would have to be 1, 2. This is the 1, 2 pair. It's not the C. This is a well, let's see. No, I'm not quite there yet. I don't know where the 6 is in that box. The 1, 2 puts a 3, 6 here. That puts a 4 in this cell because of that 1, 2, that 3, 6, and these digits. This is the 1, 2. The 4, 8 is down here. They can't be beside each other because there's no black dots. That's a 4, 8. 4, 8. I'm left with a 3, 6, 9. This is a counting digit for the same reason that's a counting digit. That's not the B. It is a 6 or a 9. This is well, because of these digits and those digits, I know that's not the B because it's a 6 or a 9. And well, I don't know that yet, do I? Anyway, what's left in this is not a 5. What's left in these 3 cells, because that is a 6 or 9, there's a 3, 6, 9 trio. The 3 has to be in the cage, the 11-sum cage. This cannot be a 6 because there's no black dot. That's the 9. This is a 6. The 6 is not here. There's a 8B there. This is the 9 because it's, or the 5 because it's not the 9. This is a 6 because we need one in the box. This down here. This is the 9. This is a 3, 5 pair. We need a let's see, how do I get from here? Okay. Whatever these are, that 3, 6 is repeated down here. That's a 3, 6. That means this is the 1, 2. This is a 3. That's a 3 or a 6 because it's not a 4, 8, and it's next to a 1, 2 without a black dot. So that is the 3. That is the 3. This is the 6. That 3 sees a 5. This is a this is a 1. Well, this is the 6 because the 6 can't be next to the 3. This is the other 1, 2 in that pair. This is the these are all not 3, 6. They're 1, 2, 4, 8. That's a 3, 6. This is a 1, 2, 4, 8. This is a 1, 2, 4, 8. There's a 3 in this box. It can only be here. Can't be next to the 6. This is a pink digit. This is it can't be a 3, 6 pair. It's got to be a 1, 2, 4, 8. That also is connected to one of them. That's a 1, 2, 4, 8. This is the 6 in the column. This is this 3. It puts a 3 here. This is a 1, 2, 3. This is a 4-8 pair. Now, if that's a 4, this can't be an 8 because of the negative constraint. If that's an 8, this can't be an 8 because of the negative, because 8s can't go next to each other. This has to be the 8. There is an 8 in the cage, and that is it. This is that makes this a 4, and that a 4, and these 8s. 4s can't be next to 2s. They have to be next to 1s. The 1s are next to 2s. Or, these are not, none of these are 2s. This is not a 2. This is not a 1, 4 or a 1, 8. So that's a 4, 8 pair. This is where the 1 goes. That goes with the 2. These are not the 1s or 2s. This is not a 1. The 8 has to go next to a 2 because there's no black dot. The 4 can't go there. These are not the 4 8s. That's a 1 and a 2. This is the 1 because it's next to a 4. This is the 2. The 2 can't be there. This is not a 1, 2. It's not an 8. It's the 4. There was an 8 in the column. This is not the 4. It's a 2 or an 8, but there's a 4, 8 pair, so that is the 2. That's the 4. That's the 8. That's the 4. This is a 3, 6, one of the 3 6s. This is a 8 and a 4. These 4s see up here to that 4. The 4 has to be next to 2s. 2s go by a 1. Let's see. This is the 9. Sees a 5 and a 7 in the column. These are the 5 7s. This is a 1, 3, 5, but the 1s are, these ones put a 1 up here in the blue. This one sees that. This one sees that. This is a 1. This is a 3, 5 pair. This is a is a 3, 5, 6, 8. Is that what I got going here? Here, this is a 1, 5 pair in the column. So the 1 that goes there because of this one. That's the 5. That 5 puts a 5. Let's see. This is a 7, 9. 7, 9 pair. This is let's just pencil mark some things in here. 3, 5, 7, 8. I think that's a 3, 5, 7, 8. Left in the row, those 4. This is a 5, 7, 8. The 8 is here, not there. No, there's not an 8 there. That's a 5, 7, 9. Which means that, no, I haven't eliminated that yet. But these 5s are eliminated by that 5. That's a 3, 7. That's 7, 9 pair. Makes this not a 7. That's a 3, 8 and a 3, 8. This is a 3, 5, 8. And I've got everything pencil marked now, I think. See, let's just check quickly. Can I go through? 7s, pair of 7s, pair of 7s, got a little trio of 7s. 7, 9 pair, 3, 8 pair. 3, 5, 7, 9, 8. Oh, I've got a 3-6 pair in this row. It takes these threes out. Center mark, threes. 3, 5, 7, 8. Okay. Now I'm going to eliminate all my shading. And I'm going to start over with my yin yang shape. Why do I have 2 4s up there side by side? What did I, oh, I'm, okay. There are 8s that need to be placed here. These are 8s. No, they're not. These are the 8s, right? Am I right now? Okay. Is everything looking good? 8s, 4s, 9s. Okay. Now my yin yang puzzle. Oh, by the way, I can fix this 5 and 9. So my yin yang puzzle, I'm going to mark this with yellow. No. Yes, yellow. And I'm going to mark the 9 green. Yellow and green for the University of Oregon Ducks. These are counting digits, and that has to be green to avoid a 2 by 2. These are counting digits, and they have to be yellow to avoid a 2 by 2 with that one. These are counting digits. They have to be green to avoid a 2 by 2. These are counting digits. They have to be yellow to avoid a 2 by 2. This is the odd digit out. That's a 7. These are yellows to avoid 2 by 2s. That's a yellow to avoid a checkerboard. These cells here add to 19. Well, the showing cells add to 19. I'm going to mark those blue, and whatever that is, 5 or 7, it's an orange. This is blue to avoid a checkerboard. This is orange to avoid a 2 by 2. That's orange to avoid a 2 by 2. Now in Yin Yang Sudokus, there are only, at maximum, there are only 2 areas on the perimeter, one from each region. You could have 2 or 1 is all you can have on the perimeter. And in this case, I've got everything but one cell is all the same region in the yin yang scheme, and so they are all greens to avoid 2 by 2s with the yellows. These blues are no longer have to be marked blue. They can be identified properly as the greens, and that is a green to avoid a 2 by 2. This cage sums to 16. There's the minimum this can be is a 7 and a 3, and those a 7, a 3, and the 2 and the 4. So this 7 is the only 7 in the cage. One of these 3s is with the 7, 2, 4, and the other one is the odd digit out in that cage. This, by the way, is a green, because otherwise those greens cannot get connected to other greens. If that were a yellow, the greens would be trapped. These 2, 4, 7s, let's say if they are green, that is yellow to avoid a 2 by 2. This is green to avoid a checkerboard. This over here is what to avoid a checkerboard? Well, it's green to avoid a checkerboard. And what did I say? These two have to be, one is a 3 and the other is not like the others. They cannot both be green. Back up to where I made that green. Those are yellow. That is what they are in reality. This is a green. This is a green to escape, to be connected to another green. This cage, even though it doesn't have a sum, we know one of the cells is not like the others. That one has to be yellow. That these greens have to connect out of the box. They have to go there. They are green. This is yellow because This is the green cell in the cage. We said the yellow cell was going to be a 3. The other one is not a 3. And now we've got the puzzle basically done. Get rid of our 8 there. We got a 5-7 pair and a 3-5. That's 3. We've got 6 and a 3 and a 5, and down here we have an 8. We have, now how did I do that? What did I do? I said this is a 6, this is a 3, this is a 3, it's a 5. What have I done? How did I mess this up? Back up a little bit. Go all the way back to here. Okay, if I have no 5, I've got a 7-9 pair. I've got no 7. That's a 3-6-8. This is a 6. This is a 9. That's a 7. That's a 5. That's a 9. This is the 8. This is a 7. This is a 5. This, by the way, is a green. And a green to get out. There's a green to avoid a checkerboard. I thought I had this. Oh, this cage without a sum is just there to disambiguate those two. That's the green. That's the yellow. This is the 1. It's green. That's the 2. That's the 6. That's the 3. That's the 6. This is the 7. That's the 5. And I'm going to leave it at that because you know what comes next. I'm just going to put B's in the corner instead of 3's in the corners. And you can sing a song about bees if you want. I'm going to leave it like that so we don't have to watch the animation. Anyway, be sure to check out the YouTube channel, Cracking the Cryptic. It is amazing. My other one of these things is not like the others puzzle, was published in February. And I've submitted a second puzzle since then, and which is also on my YouTube channel. It's not like this. It has circles and black crop key dots, but it is not, it doesn't have, no, it has circles and thermometers. I am working with black crop key dots on another puzzle that I haven't published yet. Anyway, please like my video, subscribe if you don't mind. I don't put out that much, and have a lot of fun with these. Make a comment, let me know what you think. And what else was I going to say? The link to the Sudoku pad version of this puzzle will be in a comment, and I'm going to put some timestamps in here for some of my hints and corollaries. Thanks very much. Bye.